A while ago, I stumbled upon a video by Spime.im plus Akasha, and I immediately asked myself how that effect was achieved. It was clearly AI-driven, but I couldn't quite figure out the underlying mechanics. I loved the idea of creating a stop-motion aesthetic using AI-generated imagery, but the big question remained: how do you maintain a consistent sense of movement? After some thought, I remembered spending hours on Google Maps Street View as a child. I realized that could be the answer: a ready-made path through the world. To gather my raw material, I decided to mine sequences of real-world images directly from Google Street View. I wrote a Python script using Playwright to automate the process. I initialized a Chromium instance with a strict 1280 by 720 viewport. I didn't want a simple screen recording. I wanted a methodical, high-quality capture. My script navigated the virtual streets by simulating hardware keyboard inputs, specifically the up arrow key, interspersed with 3-second pauses. This delay was critical, as it allowed the Google rendering engine to fully load high-resolution textures, ensuring my starting canvas wasn't compromised by blur or artifacts. Each step was saved as a progressive PNG frame, creating a clean chronological sequence ready for transformation. As the project developed, I made a stylistic choice. I decided not to crop out the Google Maps UI. I believe it should be explicit when an art piece is made with AI. I'm not seeking a perfected image. This project is more about exposing the raw process of image alteration. With my frame sequence ready, I moved into a cloud computing environment on Google Colab. To handle the complexity of latent diffusion models, I leveraged the compute power of an NVIDIA T4 GPU. The main challenge was temporal consistency. How could I transform a city into ruins without the buildings morphing into different shapes in every single frame? The solution was integrating ControlNet into a PyTorch-based pipeline. I subjected each original image to a canny edge detection algorithm. This operation reduced reality to a geometric skeleton of lines and contours, which became the structural constraint for the Realistic Vision V 5.1 model. While my prompt described devastated cities, scorched earth, and rubble, ControlNet forced the AI to strictly follow the contours of the original street. I calibrated the strength parameter to 0.75 and the conditioning scale to 0.6, finding the balance between creative destruction and the recognizability of the location. The final part of the journey was the reconstruction. I found myself with hundreds of individual images, each a small work of generative art, that needed to return to a state of motion. For this final assembly, I chose FFmpeg for its surgical precision. I decided on a frame rate of 15 frames per second. This wasn't a random choice. I wanted a jittery, dreamlike rhythm to emphasize the artificial and brutal nature of the landscape. Using the libx264 codec and the YUV420p color space, I fused the frames into a single MP4 stream. Seeing familiar streets transform into a post-apocalyptic wasteland in seconds was the culmination of the process. A fusion of web automation, computer vision, and neural synthesis. The result, and boom. I decided to push the AI to its limit by introducing a massive amount of environmental noise, microplastics, rotting bags, and tattered synthetic waste. I didn't want the city to just look old, I wanted it to look suffocated. To achieve this, I completely overhauled the prompt. I moved away from warm, natural tones and forced a cold, monochromatic blue tint. This isn't just a color choice, it's a psychological one. It simulates the oily, suffocating haze of industrial smog. Technically, I had to crank the guidance scale up to 15.0. Usually, this would deep fry an image, making it too sharp or distorted, but here, it works in our favor. It forces the AI to render the crinkled and putrid textures of the waste with surgical precision. By lowering the ControlNet influence, I allowed the piles of trash to physically overflow from the sidewalks of a modern city, effectively drowning the world's most luxurious architecture in its own byproduct. If you found this process interesting or helpful, please consider subscribing. Thanks for watching.